Hello, I'm Chris. Welcome to Warrior. Very glad you're here. This is the next episode of a really exciting cutting edge series with UK based SAE Media and CUAS Hub experts in the realm of counter drone technology. We're working on the cutting edge of solutions to defend against drones and drone swarms. We talked to military flag officers from both the US and NATO allies. Our focus is also on industry, however, and some of the cutting edge innovations that are being offered to the military services. We are being joined today by one of the leaders, a real rock star industry provider of counter drone radars called Echodyne Systems. They are based in Washington State. First, let's welcome them, and then we'll introduce them both to this discussion of expert technologies. Thank you very much to Mr. Leo McCloskey and Mr. Evan Hunt, the Director of Marketing VP for Echodyne and the Director of Business Development, experts in this realm of technology. Welcome, guys.
Thanks, Chris. Lovely to be here.
Thanks, Chris.
Excellent. Well, let's hear from your expertise about Echodyne. From what I understand, serves government installations, U.S. military, allied military with counter drone radar technology. Let's talk about some of the places you operate, and let's dive right into the elements of the innovations which make this unique. Well, that's excellent. I mean, one of the things this calls to mind is what you mentioned, which is countermeasure integration and this idea of fire control. It sounds like Echodyne radars can do a lot of what the cutting edge discussion is about, which is make those discriminations. Let's say there's a given tactical scenario where it's too cloudy, so you can't use a laser. Perhaps it's a civilian area where you don't want fragmentation, so you can't go kinetic, so you might need EW. The ability to take that otherwise stovepiped information, to use the cliche of stovepipe, and analyze it and organize it to make those recommendations and decisions. Sounds like what you're saying. I mean, this is really kind of the goal of what the next generation of drone defense is. Sounds like you guys are all over that. I mean, not to sound so sunny, but kind of what it sounds like.
Well, Chris, you've nailed it. I mean, it really is, to Evan's point, it's about actionable data. I have a certain sort of thing when people talk about detection ranges. I try not to yawn, because detection doesn't mean anything. Detection's anxiety, right? What you need to have is actionable data. I need to be able to do something with the data. Otherwise, I'm just concerned, and my concern is not going to get me anywhere. And so when we talk about like the ranges that we publish in any of our material, these are tracking ranges. It's not detection ranges. This is, you have actionable data. You can do something about it if you're so equipped. And that to us is what's meaningful, right? To get data into the right hands as fast as possible, that has the highest accuracy, that allows smart humans and smart systems to make the choices in the shortest amount of time possible. And what we found in particular is the economics of the engagement, thinking around, what the cost of attack is and the cost to defend. We can't be spending $1 million missiles, no matter how effective they may be, at $50,000 drones. It won't work. And so what we have to figure out is the way to level that. What we've seen is a real movement in the field, and I'll let Evan get into details, of having remote weapon stations, right, where there's thousands and tens of thousands of those deployed around the world, and small adaptations of a radar and programmable airburst munitions, and boy, you have an effective drone hunting platform that we're starting to see tremendous enthusiasm for. Evan, why don't you comment on some of that?
I want to give you some fun examples, Chris, right, which will resonate, I think. Look, in the beginning, with drones, it became very apparent that the best way to detect a drone in your airspace at very long range is with passive RF frequency detection, because the commercial drones in particular were always emitting at a particular frequency. So that is a very good first line of defense. But what happens as warfare evolves is now you have dark drones that literally do not emit. You've got fiber optic drones that are nearly silent because they carry pools of fiber behind them. They lay them out, and they're FPV driven at very low altitude. And so they don't emit, they're silent. And the only way to see them at effective range for weapon systems is with radar. So this tried and true radar capability that's been used for decades now very effectively has just been upgraded to do the counter UAS mission. And that is important, because what you have with the drone threat in particular is cost warfare. So drones are so inexpensive. Like Leo said, you can't afford to be hitting them with $1 million missiles all the time. But you also, sometimes you already have $1 million missiles. You can't afford to use multi-million-dollar radars to help the missiles get there. So we're uniquely focused at Echodyne at helping weapon system providers maintain the capability they need, upgrade their capability where required, while keeping costs low. Because, you know, we're very inexpensive. We have very fast lead times for the capability we provide, and it's a real game changer for certain weapon systems, even more traditional weapon systems that were designed for other things that are now being forced into counter drone missions. Certain types of missiles, certain types of anti-aircraft guns, they get upgraded with an Echo Shield radar for relatively low cost in very little time, and now they're a counter drone weapon.
Well, that's excellent. I love what you said about APKWS, because a lot of those are those laser guided Hydra 70s. They can be fired from helicopters and planes. That would suggest there's a multi-domain component to this, because we hear about digital networking with radar nodes and radar systems. That increases range, and it adds kind of a paradigm changing attack possibility in terms of a countermeasure. It sounds like your C2 is looking in that direction as well.
We, from a radar perspective, we want to make sure that, to Evan's point, it's adaptable to your mission. If you want to use it to help train your fire control system, provide range and range rate information so you can put munition on the threat, it can do that. If you want to put it in the corners of the vehicle and drive it around as a sensor pod, it can do that. You want to fix it to a building, it can do that. You want to put it in a case where troops roll up on the beach and within an hour they're establishing, a 30-kilometer bubble of situational awareness. It can do that. I mean, it really comes down to, we can't have specialized devices for specialized applications. We need devices that perform extraordinarily well, because we can't afford to risk or to compromise safety. But we also need to have it in a way that can be replaceable, fast, and that is affordable, because we can't afford to spend ourselves into oblivion. And so, to Evan's point, that's the sort of, we have come upon this at the right time. We have the right sort of technology and capabilities. And we found that our customers, once they get a hold of the data and start piping the systems, they're doing really creative and great things with it.
Well, let's talk about security. One of the key questions and challenges with radar, and you touched on this with passive RF, how do you perform the requisite defensive mission without emitting a signature, which of course gives away location and makes the radar itself vulnerable to attack? What are some of the countermeasures or protective measures you have in place to address those risks?
Yeah, so radars emit, right? That's part of their magic, what makes them great. But there are many ways to mitigate risks associated with emission. So the first is on the move applications. We've got lots of customers that want to put radars on the back of vehicles or on their boats to be moving, right? So you emit and then you move and you emit again and then you move, and you're constantly changing your location. The other way is only to emit in the initial detection phase, and then as soon as you transition to an optic or to a weapon system, you stop emitting. So you learn to blink at the right times, because that information is too important to the operator and to the weapon system to not get. So you have to expose yourself, but you can limit your exposure by smart application. And some of that can be programmed into the radar itself. So it's not hard on the operator. It just learns to emit at the right times for a particular weapon system or for a particular mission.
That's excellent. So, Mr. McCloskey, I'd love to hear your thoughts on this. So is that kind of tailorable almost? I don't want to say frequency hopping, but this idea of algorithms could potentially do that autonomously, right?
Indeed. And there's a whole bunch of other things that play into this here. So, at a fundamental level, instead of putting 20 to 30 degree beams out, which sort of glow like a candle in the dark, we're pumping out really small, tiny 2 degree by 6 degree beams. And so we're much more directional. The radar sort of designed for this space have a better sense of spectrum hygiene. So they're just not emitting all over the place because it didn't matter before. Now it really matters a lot. And so we have a very sort of interesting profile from on a comparative basis to how it really looks from an attack perspective. And then there are some different things one can do with frequency, as you pointed out. We think it's really quite straightforward actually, but a hot standby, quick on off, so that you can